Hi, so in this video we are going to discuss about the confusion matrix. But before we get into the confusion matrix, we are going to discuss about what is the process of building a machine learning model. Whenever we are building a model, first thing that we do is we load the data. After loading the data, you process it. Basically, you do feature extraction and normalization and everything. The next thing you do is you split the data between training set and test set. Okay, the training set data is used by your machine learning model to train itself. So by this data set, your model understands what type of output is expected when a certain input is given. Okay, then we come to the validation part, where we use the test set, the test part of our splitted data, to check the validity and to measure the performance of our model, that how well our model has performed. Okay, yeah. Now, confusion matrix. What is confusion matrix? Confusion matrix is used to evaluate the performance of a model. And since it is used to evaluate the performance of the model, it is very clear that it is used on the test dataset. Okay. As I have written it once again, that confusion matrix is made up of records from the test set. Now, we will see an example and we will create a confusion matrix for our own sample dataset. Okay, so suppose we have a data set of about 70 rows. Okay, and we apply a split of 20-80, where 80 is used for training the model and 20 is used for test purpose. Okay, to validate the model. Okay, and 20% of 70 will be 20% of 70 is equal to 14, and the 14 records are right in front of us. Okay, so this was the test data set. These are the actual yes and no. Okay, and these are the values predicted by our model. Okay, and this is the additional column that I added to make our process faster. Okay, now before we actually discuss about confusion matrix, there are four terms that we need to discuss. The first term is true negative. As you can see here, true negative is the situation when the actual value is no and our model has also predicted it as no. The false negative is when the actual value is yes and our model has predicted it as no. So false negative. Okay, so it is negative but it is false. Okay, try to think, try to play some words. Okay, the next thing is false positive. So it is positive but it is false. So basically it is predicted as positive but it is actually negative. And then we have true positive, when it is positive and it is actually also positive. Now this is by the way, this is the confusion matrix that we will be making now. The first thing that comes in the set is 14. Alright, then we calculate the true negatives here. Okay, so true negatives were the data sets when the predicted value is also no and the actual value is also no. Okay, so here we have no, here we have no. Okay, we have no here and we have no here and we have no here. And how many of these are correct? This is correct. Okay, this is correct and this is correct. So three values are correct. We have three here. Then how many are the false negative that we have as no but are actually incorrect? Okay, so we have this and we have this. Okay, so two are here. Then we have false positive. Okay, how many are the positives? This is positive, this is positive, this is this and this. Okay, and how many are incorrect? Okay, one. Then we have two. Yeah, so we have two. And how many are correct? 1 2 3 4 5 6 and 7. Okay, so this is a major part of our confusion matrix is finished. The next thing that we do is we just confirm that our we have not missed any record. So we do the total and then we have 9 and all the values should be equal to the total value. And here we have 9 and here we have 5. So 5 plus 9 is equal to 14. Hence our we have not missed any record. So this is the confusion matrix that we have just created for our given data set. The main point to remember is that confusion matrix is created from the records in the test data set, okay, not the training data set. And now in the next video, we are going to use this confusion matrix to evaluate a lot of performance matrices. Basically, we are going to see how do we use this confusion matrix to evaluate the performance of our model.